Least common multiple. Let A and B be sets where A contains the multiples of integer A and B contains the multiples of integer B. So if A is an integer, and we will collect the multiples of A in set A, and so this is how it's going to be. A is equal to the set with elements A times 2A times 3A times 4A, so on and so forth. So that is how you produce the multiples of A. You just multiply it by a positive integer. With B, it is going to be equal to this. B is equal to the set that contains B, 2 times B, 3 times B. So A contains the multiples of A, B or set B contains the multiples of integer B. If A is equal to 3 and B is equal to 5, let us produce the multiples of A and B. So A or set A is equal to 3. 3 is 1 times 3. 2 times 3. 3 times 3. 4 times 3, so on and so forth. So the multiples of A goes to infinity. It does not stop. The multiples of B are 5. So that is 1 times 5. 2 times 5. 3 times 5. 4 times 5, so on and so forth. So the multiples of 5 is also runs to infinity. So what then is the LCM? What is the least common multiple? So what you do is you look for the common multiples and you will choose which is the least among the common multiples. So between set A and set B, the common multiples are 15, 30. This goes on. This has many common multiples. But the LCM is the least common multiple. And so in this example, the LCM is equal to 15. And this is our notation. When you see this, LCM and then 3 and 5, what that means is you are looking for the common or for the least common multiple of 3 and 5. How to find the LCM using prime factorization? Let us get the LCM of 12 and 30. Find the complete factorization of each integer. So 12 is equal to 4 times 3 or 2 squared times 3. And 30 is equal to 2 times 3 times 5. We will collect the prime factors and write them as a product. So the prime factors that we are seeing here are 2, 3, and 5. And so we will write it as a product. 2 times 3 times 5. And then we will find the highest exponent of each factor in the factorization. For 2, the highest exponent is 2. For 3, it's 1. And for 5, it's also 1. And so the LCM is 2 squared times 3 times 5, which is equal to 60. Since 12 and 30 are small integers, we can easily find the LCM without doing this. All we have to do is produce all multiples of 12. Okay, so what are the multiples of 12? So you have 12, 24, 36, 48, 60, and 72, and 84, so on and so forth. And now how about 30? Let us produce the multiples of 30. 30, 60, 90, so on and so forth. So right away you can see that the least common multiple is 60. When you are working with small integers, you can easily find the LCM by just listing the multiples of each integer and look for the least common multiple. Let us get the LCM of 15 and 90. So right away, I think you can already see that 90 should be the least common multiple here. 15 is 3 times 5. 90 is 2 times 9 times 5. 9 times 5 is 45. And so times 2 is 90. So the LCM is, we will copy the prime factors and then we will affix the highest exponent of these prime factors in your factorization. So for 2, the highest factor is 1. The highest exponent is 1. For 3, the highest exponent is 2. And for 5, the highest exponent is 1. So the LCM is this. It's 2 times 9 times 5, which is equal to 90. How about 24 and 50? What is the LCM of 24 and 50? This is where it becomes more challenging. I mean, writing out the multiples in a set form, that's going to consume a lot of time. And you are going to list many multiples. It is in problems like this where the steps which I enumerated becomes helpful. So let us produce the prime factorization of 24. 24 is 8 times 3. And 8 is 2 cubed. 50 is 2 times 25. So the LCM is, so you will copy the prime factors 2, 3, and 5. And the exponent that you will affix to each factor is the highest exponent that you are seeing in the factorization. So it's going to be 2 cubed times 3 times 5 squared. That is equal to 600. How about the LCM of 3 integers, 20, 36, and 50? Let us produce the prime factorization of each integer. 20 is 4 times 5. 4 is 2 squared. 36 is 4 times 9. 4 is 2 squared. 9 is 3 squared. 50 is 2 times 5 squared. This is the LCM. So again, you will write the prime factors that appear in your factorization. It's 2, 5, and 3. 2, 5, and 3. And you will affix the highest exponent of the prime number that appears in your factorization. So for 2, the highest exponent is 2. For 3, it's 2 again. And then for 5, look at this. You have a 5 here and 5 squared here, but you will choose this. It's 5 squared. So this is the LCM. It's 2 squared times 3 squared times 5 squared. You do the math, and it will give you 900.